Hello everyone, this is Dr. Gomathi, Assistant Professor, Department of ECE, SA Engineering College. In this lecture video, we are going to see about Booth algorithm, this Booth multiplication algorithm. So Booth multiplication algorithm is used to perform multiplication of two signed binary numbers in 2's complement notation. So now we will see the hardware implementation of Booth algorithm. So in this hardware implementation, we use 4 registers. So among these 4 registers, B register is used to store the multiplicand and Q register is used to store the multiplier. Whereas in order to perform the multiplication process, we use 2 inputs. One is the multiplicand and another one is the multiplier. So B register is used to store the multiplicand and Q register is used to store the multiplier. Other than these 2 registers, we have a special register called as A register and another 1-bit register which is nothing but Q register. So since Booth algorithm, it is a 2's complement multiplication, so that we use one XOR gate and a n-bit adder, and then we have a control logic. This control logic will produce the necessary control signals in order to check the condition and also in order to do the shifting operations. And then we have a sequence counter which is used to count the number of counts, so that when the count becomes 0, the multiplication process is going to be ended. So now we will see the flowchart for Booth algorithm. So we have the 4 operators such as, that is 4 registers A, Q, M and Q, that is Q register which stores the multiplier and M register which is used to store the multiplicand, and A register. Once after performing the shifting operation, the result is going to be stored in this A register, and initially the A register and Q minus 1 register will be 0 and count will be N. N is nothing but number of bits in both multiplicand and multiplier. If the number of bits in multiplicand and multiplier is 4, then the count will be 4. So after loading all these values, the multiplicand and multiplier and the initial values, we are going to check the condition. So what is the condition is, when Q0 and Q minus 1 is 1 0 or 0 1. That is, when Q0 and Q1 is 0 1 means, then we are going to perform the subtraction operation. And when Q0 and Q1 is 0 1, and then we are going to, for this condition, we are going to perform the addition operation. If Q0 and Q minus 1 it is 1 1 or it is 0 0, then we are not going to perform any addition or subtraction operation. Directly we can move to shifting operation. So by step, for each step the count is going to be decremented. So at the last step, when the count becomes 0, we are going to end this process. So now we will see this, we will implement this algorithm with an example. So we'll move on to the example now. So I took an example, that is multiplication process of minus 7 into 3 using Booth algorithm. So that the first input I am taking as multiplicand, which is going to be stored in the B register, which is nothing but minus 7. So the 2's complement, always the negative numbers are represented in 2's complement form. So the 2's complement of minus 7 is 1 0 0 1. And the multiplier is stored in Q register. The input which is given in the question is 3. So the binary equivalent of 3 is 0 0 1 1. So now we will implement this flow chart, that is we will implement the steps in this problem. So we will write the initial things, that is A register, initially it contains 0 0 0 0 because N is nothing but 4. Number of bits in multiplicand and multiplier is 4. So that we are going to store 4 zeros in A register. And Q register, which is used to store the multiplier, the value of multiplier is 0 0 1 1, and Q minus 1, initially the value will be 0. So we will be writing the initial step. So at this initial step, the count value will be 4. Why? Because the number of bits in both multiplicand and multiplier is 4. So once after initializing all these registers, we are going to check the condition. So who is going to check the condition? The control unit will provide the necessary control signals to check the 2 bits, which is nothing but Q0 1 and Q minus 1. Q0 is nothing but the LSB of this Q register. So when this Q0 and Q minus 1 is 0 1, 0 1 means, so we are going to perform the subtraction operation. After performing the subtraction operation, the result is going to be stored in A register. So I have given the calculation in this here. So calculation for A minus B. A is nothing but the actual input, which is nothing but 0, 0, 0, 0. Minus B is nothing but we are going to represent the negative numbers in 2's complement form. So B is nothing but 1, 0, 0, 1. So minus B means first of all we are taking 1's complement and then we are going to add 1 so that it becomes 2's complement. So taking 1's complement for 1, 0, 0, 1 it becomes 0, 1, 1, 0 and adding 1 to the LSB it becomes 0, 1, 1, 1. So this is nothing but 2's complement of B. So now we are going to add this, that is A minus B is nothing but we are going to add A with 2's complement of B. So adding this I have performed here. So initially A value is 0, 0, 0, 0 and 2's complement of B is 0, 1, 1, 1. Adding these two values we are getting 0, 1, 1, 1. And then the value in Q register is 0, 0, 1, 1 and the value is Q minus 1 is 0. So after performing the subtraction operation, we are going to do the shifting operation, that is we are going to shift the bits towards right side. So always the MSB should be preserved. So preserve this 0. After preserving, shifting should be started from this bit. So MSB is shifted to the next bit towards right side. So 1 is shifted here and finally 0 is shifted here, 0, 1 and then 1. Now Q minus 1, initially previously the value, the 1 bit register contains 0. Now after the shifting process, the 1 bit register 0 is replaced with 1, that is 1 has been shifted into Q register. So after this is your step 1. So after your step 1, initially your count is 4, now count minus 1, 4 minus 1 it becomes 3. So now we will move on to the next step, which is nothing but step 2. So I am taking and writing this again, that is 0, 0, 1, 1, 1, 0, 1, 1, 1 again. After writing this, again I am going to perform from the first step, that is I am going to check the condition Q0 and Q minus 1. So now Q0 and Q minus 1 is 1, 1. So when the condition is 1, 1, then the control unit will provide the necessary control signal to just shift the bits. So I am going to preserve the MSB and I am going to shifting the bits towards right side. After shifting, now previously in step 1 the count is nothing but 3. Now after completing the second step, now count becomes 3 minus 1, it becomes 2. So after completing step 2, we are move on to step 3. I am taking and writing the above thing, that is 0, 0, 0, 1 in A register, 1, 1, 0, 0 in Q register. Now Q minus 1 contains 1. And then again I am going to check the two values, which is nothing but Q0 and Q minus 1. So now Q0 and Q minus 1 is 0, 1. So when it is 0, 1, we are going to perform the addition operation. So A plus B, A is nothing but now A contains 0, 0, 0, 1 and B contains 1, 0, 0, 1. So adding these two things, that is A and B, we are getting 1, 0, 1, 0 and then the Q register contains 1, 1, 0, 0. So after performing the addition operation, we are going to do the shifting operation. So preserve this MSB. After preserving, we are going to shift towards right side by keeping this MSB. So 1 comes here, 0, 1 and then 0, 1, 1, 0. Now this 0 is going to be shifted to Q minus 1. So previous step in step 2, the count is 2. After doing the step 3, now count becomes 2 minus 1, it becomes 1. So now we moving on to the next step. I am taking and writing this 1101 which is in A register and 0110 which is in Q register and Q minus 1 contains 0. Again we are going to check the condition, which is Q0 and Q minus 1. Now Q0 and Q minus 1 is 0, 0. So as per the condition, when both the bits are 0, 0, we are not going to perform any addition or subtraction operation. Just we are going to shift towards right side. So preserve this one and after preserving, shift from this MSB. So 1 comes here and 1, 0, 1 and then 0 comes here, 1, 1, 0, 0. So now count becomes 0. So as per the flow chart, when count becomes 0, we are going to stop the operation. That is, we are going to stop the multiplication process. So now we are going to check the condition, that is we are going to check the answer whether it is right or not. So now check the MSB. As the MSB is 1, now we can predict that the answer is nothing but it is going to be a negative number. So when it is a negative number, again we have to take the 2's complement for this answer, that is the content present in the A register and the content present in the Q register. So taking 2's complement for this 1110 1001, taking 2's complement, first initially I am going to perform 1's complement and then I am going to add 1 to the LSB, so that the answer is nothing but 0001 0101, which is nothing but minus 21. Okay, so this is the answer for the solution, which is minus 7 into 3. So this Booth algorithm is which is used to perform binary multiplication, especially for signed numbers. So we'll see the modified Booth algorithm in the next lecture. So thank you all.